Thank you very much indeed, Rob, and it's a pleasure to be here. So you see the title, Science Advice and Government the Next 5 Years, but I thought, being in my third week of the job, that it ought to have a subtitle, and of course the subtitle is A Work in Progress. So this is, for me, I'm at the start of this job, and I think that I have a lot to learn. I think we all have a lot to learn about how to do this collectively in the most effective fashion. So these are, I think, the 5 themes which will underpin the work of the Government Office for Science for the next few years. Government cares about the economy. Government cares about the security, the well-being, the health of the people that live in the nation. And this is not an audience, I think, that needs a lot of persuasion that science, engineering, technology, and social science are integral to the advice that government needs in order to develop and implement the best policies. So, taking the economy, it's about how we take the extraordinary science base in the United Kingdom and turn that to the best economic advantage. On health, on well-being, it's our infrastructure. And as I've said before, one of the things that distinguishes economically advanced societies from those that are poor is the quality of the infrastructure. And one of the privileges of working at the Wellcome Trust for the last 10 years has been the work that we supported in the developing world, but you only had to visit some of the poorer countries in Africa and compare the infrastructure to realize how profoundly important it is for the way we all live from day to day. And we take it for granted, and it's only when infrastructure goes wrong, when just-in-time supply lines, for example, don't operate properly, that we realize how fragile our advanced infrastructure actually is. Again, there's no one in this room that needs persuading, I think, that wherever possible, we should underpin policy with the best possible evidence. And of course, science, and I'll use science as the shortcut, but I do in all cases mean science, engineering, technology, and social science. But it would use too many words if I used it every time. Science is very important in emergencies. And then finally, I think that the Government Office for Science has an important role for leadership in science, both inside and outside government. So those are the 5 themes, and I'll spend the next few minutes delving into each of them in a little bit of detail. But I think one of the key issues is that people tend to look at almost any issue through a single lens or one of the single colors of the rainbow. And so prisms and lenses, I think, are good optical metaphors for the different ways in which we need to look at things. So in order to tackle difficult issues, energy, almost anything, you need to actually look at it through each of the dimensions. And let's just take an example, sentencing policy. So in the criminal justice system, sentencing has 3 different roles. It's aimed to prevent people from reoffending and to rehabilitate people who have committed crimes. It's intended to deter others from committing crimes. And thirdly, there's a clear element of societal retribution. Now, the challenge is that some of this is amenable to experimental evidence, other bits of it are not. So you could do controlled studies to work out whether different types of sentencing would prevent reoffending. But it's quite difficult to know what study you would do to determine the retribution element. And I think it's a very good example of where both science and judgment come together in the formulation of policy. So there are 2 points of this slide. First, that actually if you look at any issue through a single lens, you'll miss the diversity of issues that surround it. And secondly, in policy, the very complicated interplay between evidence-based decisions and decisions where there is, frankly, an element of wisdom and judgment. So let's start with knowledge to growth. This isn't, of course, linear, as everyone in this audience knows, but it starts with imagination, it starts with creativity, it starts with basic science, with engineering concepts. But of course, the imagination is not sufficient on its own. There needs to be innovation. There needs to be the recognition that a discovery in the laboratory is something that can be turned into a product that might be useful, that might indeed make money. There are then the skills of entrepreneurship, how you actually do it. But even that's not sufficient, because you then require the business skills to raise the financing, to actually run the business. And ultimately, you need the skills of manufacturing, but that's not enough. You need branding skills, you need marketing skills, you need to be able to distribute. And on the right, you see the patent that Frederick de Moleyne took out in 1841 for electric incandescent lighting, but it was Edison that actually captured the market. And I would submit that we are very good in the UK at each of those 5 areas of activity. We have an extraordinary science base. I've just come back from Geneva, where the Louis Jeantet Prize for Science, which is awarded to European scientists each year, was awarded to Mike Stratton, amongst others, the director of the Sanger Institute, who's made extraordinary basic discoveries in cancer genetics, which are now being translated into new treatments. And British scientists have won about a third of the Jeantet Prizes in the 30 years of its existence. We're good at innovation. We're good at entrepreneurship. I think one of the challenges for us is how we join these up. And I've joined them with arrows going in both directions, but this is a very complicated cycle, and one could make a very messy diagram by drawing arrows in every direction. So I think one of the challenges for all of us is what's actually holding us back from turning that extraordinary imagination into products that make serious money, that create serious employment, and that strengthen our economy. And I think the challenge for us is to be catalytic and to break down the barriers. Now, in fact, we're also good in the UK at barriers. And the slightly unaesthetic photo on the right is an example of a British barrier. And I've learned since I've been in this job that we're not only good at barriers, we're good at bollards. And there is a very serious point here, of course, because this is we don't really need reminding today of the importance of defense against terrorist attacks and other attacks. But we need to break down the barriers in the context of knowledge to growth. And I think that work is probably required on each of these bullet points. And as I say, this is a work in progress. We need to make sure the incentives are in the right place and that we don't set out perverse incentives. For example, I'm not sure that a useful metric is the number of spin-out companies from a university. The metric surely has got to be successful spin-out companies that actually make money. We have to manage intellectual property know-how in the best way. We have to protect it, but we mustn't overvalue it, and in doing so, prevent its exploitation. We have to optimize the technology transfer machinery. We need to look at environments. So, for example, the science park outside Cambridge is clearly an example of an extraordinarily catalytic environment. And we need to understand those. I don't think anyone would disagree with the idea that we need to work on skills and on leadership. We need to look at the funding. Are the capital markets fit for purpose? Have investors the right time horizons? Do companies get sold too early? We need to look at regulation. a big challenge is business absorptive capacity, because the fate of many companies is to be bought by a big fish, so a minnow swallowed by a big fish. Do we have the absorptive capacity to grow companies in the right way? And of course, there's only any good in producing things if there are customers for them. And of course, government itself is an enormous customer. And is government the most effective customer? Because that's important also in terms of the development of that knowledge into growth. And I suspect there are more. And it's much easier, I think, here to make the diagnosis than it is to provide the solution. But I think this is an area that is critically important for all of us. And we do have a tendency, I think, to beat ourselves up too much. There are some extraordinary examples of success, and here's an example of a Cambridge software company, Real VNC, and I suspect all of us are familiar with when computers go wrong, people operating them rather magically, remotely, and you see the sort of cursor moving eerily across the screen as someone afar is operating your computer. Well, this software developed out of developments in the Cambridge Computing Department and is being turned into important businesses. Now, let me move on to infrastructure, to the whole question of resilience. And here, and I've again chosen to illustrate infrastructure, transport infrastructure in this case, in the developing world, and contrast it with a spaghetti junction down below. But these are some of the challenges in what I've called the engineered world. So the challenge of energy, of communications, and of course particularly internet communications, cyber infrastructure, cyber security, which has become a critical part of our everyday lives. And boy, do we get cross if the internet doesn't work properly for us. Transport, the built environment, the management of waste. And one of the critical issues with all of this is that each of these infrastructures is intimately interconnected with each of the others. And so if the electricity supply goes, pretty much everything else goes as well. The traffic lights stop working. The internet stops working. And understanding those complex interconnections, which create vulnerabilities all on their own, is absolutely critical. And then there are the infrastructure of the natural world. And at some level, this is a slightly arbitrary distinction. But there's the environment, the climate, the weather, and something that there's much more attention to at the moment, which is the whole issue of space weather, of ionizing radiation, electromagnetic radiation from the sun. The whole question of food and water, which of course is a mixture of the natural environment and the engineered environment, and health. And again, you see the contrast between the well on the top and the massive concrete dam on the bottom. So each of these offers hugely important challenges to government, to all of us, and scientific advice is essential in analysis. But let's just take an example of one of those areas, and I want to make the point again that you have to look at any one of those areas through different lenses. So if you take energy, and energy is obviously crucially important for the future of every nation, then we need to look at energy policy through at least three different lenses. We need to look at it through the lens of security of supply. We must have secure supplies of energy. You need to look at it through the lens of cost. It has to be affordable. The economy is driven to a significant extent by energy prices. And thirdly, we have to look at it through the lens of environmental sustainability, the sustainability of the planet. But if you try and solve the problem of energy by just looking at it through one of these lenses alone, you're very unlikely to come up with the comprehensive range of policies that's needed to provide the energy supplies that we need for the future. And I think that some things are clear about energy going forward. we need a diversity of different sources of energy. There are many areas where we need specific advice, and I'll give one very good example, and I'll come back to how the Government Office for Science is going to seek advice. This, on the right, shale gas extraction in the UK, a review of hydraulic fracturing, is an absolutely excellent report commissioned by the Government Office for Science and provided by the Royal Society and the Royal Academy of Engineering working together. And I think there will be many examples where specific advice is needed on aspects of the science of the delivery of energy. I think the third thing that's absolutely clear is that with energy we do need long-term planning. And finally, there is a very complicated interplay between engineering, economics, and politics. Let's take the issue of underpinning policy with evidence and go into the area of food security. And this is an area of active discussion and debate in Europe at the moment. And that's the question of the safety of the application of neonicotinoid insecticides, and the question which is being debated very actively at the moment as to whether there should be a moratorium on their use in the European Union. And it's worth pausing just for a second to remember that neonicotinoids were introduced in 1993, and they are chemically derived from natural plant compounds. And of course, nicotine itself is a rather well-known plant-derived compound. And they probably, in evolutionary terms, have been part of a plant's host defense against insects. One needs to view the issue of insecticides through, I think, 4 lenses. Firstly, there is an enormous amount of focus because of the very strong human relationship with bees, particularly honeybees, although it's worth saying again that it's actually the bumblebee that is much more sensitive to neonicotinoids than honeybees. But there's one lens looking at the question of the potential harm to bee populations due to neonicotinoid and indeed other insecticides. And bees, of course, are undoubtedly an environmental good, and they're important pollinators. But actually, in a way, they're an iconic symbol of insect and plant diversity, and indeed pollinators in general. And I think there is little doubt that globally pollinators are in some difficulty. But of course, why do we use insecticides? It is because we need to have crop yields that are sufficient to feed the world. And I think in the discussion of insecticides, it's also sometimes forgotten that insecticides are extremely important in the control of many of the important vectors of human disease. And so dengue, malaria, sleeping sickness are all insect-borne, and insecticide-treated bed nets have been an extremely important part of the control of malaria. So what about the scientific evidence? Well, the available evidence for harm to pollinators is equivocal. So there is true uncertainty. Bees treated with neonicotinoids in laboratory or in semi-field conditions, there are signs of harm. There's abnormalities of foraging behavior, and colony growth is affected. But studies that have been done in the field, in circumstances where insecticides are applied in farming situations according to farming guidelines, have not shown clear evidence of harm at this stage. And it is clear that there is uncertainty. So should there be a moratorium now? Well, the question is what happens if you stop using them? And the economic impact of withdrawing yet another class of insecticides is potentially quite damaging, and they have been in use for 20 years. And so I think the other side of the coin is, if we're to look at issues through a multiplicity of lenses, then we have to take a multifaceted approach and excuse these metaphors, but I thought an insect eye was a very good way of showing a multifaceted approach to tackling the problems of pollinating insects. Because we won't solve the problems of insect pollination by attack on a single pathway. So we have to evaluate the effect of increasing the diversity of flowering plants in the margins of fields. We've got to look at ways of increasing the diversity of flowering plants in general. We've got to use novel ways of culturing plants. We've got to take advantage of natural plant defense mechanisms and biocontrol mechanisms. We frankly have to do more experiments to reduce the uncertainty about the toxicity of pesticides when they're applied in the field. And science is actually about reducing uncertainty by observation and by experimentation. We've got to make sure that pesticides use complies with the guidelines. And of course, what we really have to do is to use new technologies so that ultimately our dependence on pesticides and indeed herbicides is reduced. And that takes me to another currently contentious issue, which is genetic modification. And one of the things I would say about all of these things is, again, we tend to talk about technologies generically, but they're not generic. When we talk about genetic modification, it's what organism with what gene for what purpose. And that's how we have to look at genetic modification. So it's clear that conventional crop breeding, which of course is a form of genetic selection, has changed plants dramatically. And compare the image from Rothamsted of wheat from the 1940s with wheat from the 1990s. But there's a limit to what can be achieved. And we now have the opportunity to use the fruits of genome projects for directed breeding programs where you can actually select the marker that you want to breed in. And there is significant potential for genetic modification as a way of reducing our need for pesticides. And one of the challenges is that the UK, again, is actually extremely good at the basic science of plant genomics and genetic modification. But we are nationally and in the context of Europe restricted in the application of that science. And standing at this lectern, I just remind us that the Royal Society in October 2009 produced a report on genetically modified crops called Reaping the Benefits, Science and the Sustainable Intensification of Global Agriculture. And I think almost everything in that report still stands, and it made a number of powerful recommendations. So here is a simple example. This is potato blight. And again, and I'll come back to James Wilsden telling us we should look backwards as well as forwards, I think everyone in this room will appreciate the devastating consequences of potato blight in Ireland in the 19th century. It is a devastating fungal infection. And here is an example from the Sainsbury Laboratory in Norwich of a gene which has been transferred from another species of Solanum called VNT1, which confers resistance on potato blight. And that gene has been put into the Desiree potato, well known to all of us who buy our potatoes in supermarkets. And you can see the effect in terms of protecting that potato against potato blight. And this is a technology that has huge potential in terms of reducing our need for other forms of pest and herbicide control if we can actually make important food crops resistant by genetic modification. So let me move on now to science in emergencies. And I want to, again, emphasize at this point that we really do need all the sciences in emergencies. Social science is actually very important in emergencies that affect potentially large populations. How will people behave? How should we provide the best advice? So it's all the sciences. And again, I don't think this is contentious. Science is essential to predict, to monitor, to mitigate, to respond, and to clean up after emergencies. And one of the things that I've learned about since starting the job is that we have a very sophisticated infrastructure in the UK. The Cabinet Office has the Civil Contingencies Secretariat. Very considerable work goes on in terms of creating risk registers, and there is a national risk register which is available, in contingency planning, in exercises to actually rehearse the potential events. And there's also a well-rehearsed structure for providing science input in emergencies. And this gives you an idea of the National Risk Register for 2012, looking at some of the hazards. And on the ordinate, the y-axis, you can see the relative potential impact. And of course, all of these are judgments. And depending on the nature of the event, they may have more or less impact. And on the right, you have an estimate of the relative likelihood. Now, it's always much easier to predict the past than it is the future. And these are the best guesses that we can make. And you can see, for example, the potential importance of pandemic human disease. And again, in the news is a H7N9 influenza, which is breaking out in China at the moment. You can see space weather, to which quite a lot of attention is being paid at the moment, and a whole list of things. And science has a well-established place in the COBRA processes for dealing with emergencies, and COBRA, incidentally, stands for Cabinet Office Briefing Room, has nothing to do with toxic snakes. And there is a scientific advisory group for emergencies chaired by the government chief scientific advisor that feeds directly into COBRA. And of course, that group takes advice from appropriate experts, depending what the emergency actually is. And my predecessor, John Beddington, had to deal with pandemic flu, with volcanic ash, with Fukushima, and all answers on a postcard, please, for 2013, 14, etc. But SAGE is involved in the operational response, in the impact management, in the recovery, and also in providing public information. And let me say a little bit about Fukushima, I think well known to everyone in this audience. And the question is, why would the government chief scientific advisor in the UK get involved in that? Well, for a very obvious reason, and that is that the Foreign Office, through our embassies and missions internationally, has responsibility for the well-being of UK citizens abroad. And advice was needed fairly acutely on the radioactive implications for British citizens living in Japan. And of course, it was an enormous earthquake. It was magnitude 9. It caused widespread infrastructure damage, including to the Fukushima nuclear plant. And the question is, what were the implications? And in that situation, COBRA requested that SAGE met and considered what's called the reasonable worst case scenario, which is a sort of sensible way of approaching an emergency to work out what the reasonable worst case might be. There's great expertise in modeling plumes, what happens when toxic substances are sprayed into the atmosphere, how the wind conditions, how the particles will be distributed. And SAGE took expert advice and was able to advise that even in the reasonable worst case, the danger to British citizens in Tokyo was negligible. That advice was made available in a very transparent fashion. The advice was accepted. And interestingly, UK nationals did stay in Tokyo, and a number of other countries evacuated their citizens. Now, that actually turned out to be an important piece of diplomacy, because the UK advice was correct. There was minimal radiation exposure to citizens in Tokyo. It helped to calm down the public response in Japan itself, and it's turned out to be very good for relationships between the UK and Japan. And it makes, I think, another point, which is that we probably rather underplay the power of science in diplomacy. We share a lot of the issues, and many of the fundamental scientific questions are not fundamentally those that divide nations. Now, one of the privileges of my position is visiting scientists inside government, outside government, in industry. And one of the things I've done early in my tenure was to visit the Met Office, which is extraordinarily impressive in terms of the science and the work that it does. But one of the things that was particularly impressive was the integration there of the Met Office with teams from the Environment Agency who have models for surface water, for river flows and such like. And what's starting to happen is that there is a natural hazards partnership which has developed, which brings together our critical national and indeed global scientific infrastructure, so that one can start combining the capacities that the different organizations have, so that we can be much better at managing hazards, identifying them, mitigating them by providing appropriate warning. And this is something where I think the UK is potentially going to be absolutely world leading. And that's obviously important for ourselves, but also for our opportunities to provide advice internationally. So let me finish with the whole question of leadership for science, where I've broken it down into a small taxonomy. The first, obviously, is the question of the funding for science. And the UK spend on R&D in 2010-11 was £10 billion. This is a lot of money, split by, in the way that you can see on this pie chart, between research councils, between departmental budgets, between HEFSI. And I would argue that we must collectively make the case for strengthening this funding. And part of that is that we must collectively demonstrate the benefits, because £10 billion is a lot of money, and there need to be benefits for that expenditure. And the refrain of the scientist confronted with the minister has historically been, well, minister, you must understand that it will take at least 20 years from the very basic research that's going on in my laboratory to have an economic impact. And of course, that is a perfectly reasonable answer. The only problem is that that was the answer people gave 20 years ago as well. And so I really do think that we have to be much more systematic in collecting the evidence of what did happen as a result of the funding that happened in the past. And I would submit that I think there are an awful lot of examples out there, and I'm not sure how effectively we have captured them. And so here's another example from the Cavendish Laboratory of Physics in Cambridge, where flat screen technology, and indeed LCD work in general, has flourished on the basis of basic science done in physics departments in the UK. So pioneering work on LCD displays done in the UK in the 60s and 70s has now turned into Cambridge display technology. And I think just relatively recently, the picture at the bottom shows the world's largest 4K OLED display, which of course is very thin. And this is another example of very fundamental physics turning into products which are likely to become ubiquitous. I think another part of leadership for science is how we engage the public. And of course, a bit like my point about GM not being generic, the public is not generic either. There is no single public. We're all the public. There are lots of different constituencies. I think it's now well recognized, and it was work done here. It's not about correcting the deficit in knowledge. It's not us educating an ignorant community. That's not what it's about. It's all too easy to be at cross purposes. And people also talk about trust, and I think Honora and Neil has made this point on a number of occasions. Trust is not something that's generic. It's very specific. And so it's not trust me, I'm a scientist. It's trust of a scientist in a particular context. And as we all know, some of those contexts are much more difficult than others. One of the challenges for us is that, sadly, rational arguments will not always, or indeed completely, work. But that is not an exhortation for us to respond in an irrational fashion. It's just to recognize that this is a difficult topic for which there is no single magic bullet. So to wind up, there's no question that I will need your advice collectively. We need, as a community, to be proactive, and I've always said the Government Office of Science can only be as good as the quality of the advice that we receive. I think that I and my splendid colleagues will spend a lot of time engaging with the community of scientists in academia, in industry, in all sorts of different environments. We'll work with you to see if we can understand what, if any, are the barriers to growth. There's undoubtedly an important role for the learned academies and for other bodies that can provide rigorous and independent advice. There's actually a very large community, and there's an estimate of numbers here. There's about at least 3,000 and probably more scientists working through government science and engineering. And John Beddington did a lot of work with the office to start to build that into a community. And I believe that there's tremendous expertise in there. Of course, there's now chief scientific advisors in effectively every department of government virtually. The GCSA is just one, hopefully not weighed down and crushed by this enormous column of scientific advice. James recently suggested that we should, rather than having foresight, or in addition to having a foresight unit, have hindsight units. I'm afraid I think that's exactly the wrong answer, actually, because what we need to do is we need to integrate the two. We must look both forwards and backwards. And I have no doubt that more historical analysis is going to be important. And for example, Virginia Berridge's work on alcohol, the history of alcohol, was important in advising government in the past. And I like this quote and have used it fairly frequently recently by George Santayana, that those who cannot remember the past are condemned to repeat it. But I also like the book by Cornford called Microcosmographia Academica. And again, since we're going to be historically rigorous, James, you mixed up your Cornfords. So in the book you have Frances Cornford, who was Francis Cornford's wife, who was a poet, and she wrote this rather poignant verse about Rupert Brooke in 1910. A little, I think, could she have known how prophetic it was. A young Apollo, golden-haired, stands dreaming on the verge of strife. And I don't think in 1910 she would have known what was going to happen in 1914. Magnificently unprepared for the long littleness of life. Well, of course, he had a short largeness of life, I think. But Francis MacDonald Cornford, the great classical scholar, is actually the man that wrote Microcosmographia Academica. And he wrote, "There is only one argument for doing something. The rest are arguments for doing nothing. The argument for doing something is that it's the right thing to do. But then, of course, comes the difficulty making sure that it is right." And he then enunciates a couple of further rules about, and this was a book, it was a satire on university politics, but it's, I think, for anyone that walks the streets of Whitehall, it's a very good book. And it turned out that he's also quite a good artist. And the caricature on the right was actually something I bought off eBay. And it reminds us that austerity is not by any means new. It reads, during the suspension of cabinet government, ministers are requested to inform one another of the needs of their departments by advertisement in Trafalgar Square. And these are the various advertisements. The army must not have men from the army. The army must not have men from the land. So plus ça change. But I just want to end with another piece of history, which is a quote from the famous Haldane report, which I think we're going to put on the web in its full form because it's often quoted from but rarely read. And what Haldane wrote, and this was another report at the end of the First World War, it was from the report of the Machinery of Government Committee from the Ministry of Reconstruction in 1918. And what Haldane wrote was, "Turning next to the formulation of policy, we have come to the conclusion, after surveying what came before us, that in the sphere of civil government, the duty of investigation and thought as preliminary to action might with great advantage be more definitely recognised. It appears to us that adequate provision has not been made in the past for the organised acquisition of facts and information and for the systematic application of thought as preliminary to the settlement of policy and its subsequent administration. And I think we would all say aye to that. Thank you for your attention.
Well, thank you very much, Sir Mark, for a fascinating and introductory talk, setting out what I think is a demanding agenda for the next 5 years, demanding on the science community, demanding on government and its use of science, and it looks particularly demanding on yourself and the Government Office for Science as you tackle a huge range of issues, including growth and doing so at this time. I think we have maybe a chance for 2 very quick questions, and then Sir Mark will have to leave, and then we'll move straight on to the next session, which picks up many of the themes. So we'll have a more extended opportunity for discussion after the next round. But I might just take 2 quick questions of clarification at this point. And I have...
Got lots of hands.
Lots of hands. I can ask if Ben Martin, because I recognise, and Dougal Goodman, because they're sitting quite close to each other, if you'd both stand up and say who you are. Well, you don't need to do that now. Or you can.
Ben Martin from Sprue. Thank you, Sir Mark, for a very impressive presentation. To do that in week 3 is an extremely impressive task. It's taken previous chief scientists perhaps 2 or 3 years to get that.
So what's the sting in the tail?
They have, to their credit, a number of important contributions, setting in motion foresight, showing that science can play a major role in dealing with national and international emergencies, putting in place chief scientific advice to different departments. In 5 years' time, what will we be lauding you for as your major achievement?
Oh gosh, that sounds like a sort of the interview questions all again. Well, I mean, I suppose the answer has got to be the test of what progress we've made against those 5 criteria. Some of it is unpredictable, but I think the whole question of strengthening growth has got to be absolutely crucial. I think strengthening resilience has got to be absolutely crucial. It's all important stuff, and I'm not sure that I want to come out with a set of either perverse incentives for me.
Thank you.
I'm Dougal Goodman from the Foundation for Science and Technology. I was just going to take you up on one small issue. You emphasise the connection with knowledge to growth through manufacturing, but 80% of the economy or more is in services.
Yeah.
How are you going to connect with services?
No, that's of course that's an absolutely fair point, Dougal. We are good at services, and we're already talking to the city, for example, so I think the answer is in the next version of this talk, I will have services there because I recognise them. I've already had a meeting with the Governor of the Bank of England. We're going to have a session with them. You're absolutely right. And actually, the city is sometimes not thought of as an R&D intensive activity, but it absolutely is. So the point is well taken.
Thank you very much. Well, I think that illustrates both the openness that Sir Mark's bringing to the role and also your subtitle. It's a work in progress. Thank you very much, Sir Mark.